see. Okay, now we have the recording ongoing. Welcome everybody to our webinar on testing. Nico will be the main star of the show today, talking about the topic. I'm the head of marketing here at Measure Labs, and I will be here as a technical host and to try and solve if there are some issues. Some practicalities to start with. You will get the recording and you will get the presentation slides. I will send those to you hopefully tomorrow, but if not tomorrow, then during this week anyhow. And you can post questions in the chat as they come to your mind, and we will take them either as we go, if they fit in with the topic and the flow, or we will get back to them latest at the end of the presentation in the Q&A section. And we apparently have some note taker in the chat. That's okay as well to get a summary. And yes, about questions after the presentation, you can also raise your hand and unmute yourself if you want to ask a question live or participate in the discussion. And as a kind of technical advice, if you want to change the layout of how you are seeing the meeting, you should be able to do that in the 3 dots with more options at the lower bar of the meeting screen. But with this, I think I can pass the floor to Nico, and if you share your screen instead of me, I think that is easier.
Yeah, I think it's a bit more practical that way, I agree. Just a second, I find the right window. On my end, it looks like it should be visible okay, right?
Yes, it's looking good.
I hope there's not any distracting background sounds coming from the other side of the room, but I hope not.
Yeah, not for the time being, at least.
Okay, well, that's good. That's good. Only distraction for me. Yes, our toddler is having a bit of a tantrum there, so nothing to worry about. All right, but yeah, so thanks a lot Fanny for the introduction, and it's wonderful to see that so many people decided to join today to our webinar, which just only highlights that how relevant topic this is for many people at the moment. So my name is Nico Markkinen, and I'm here to talk to you today about bisphenol testing of food contact materials, and not only testing about the regulatory framework and things like that. So I've been working about 3.5 years now at Measure Labs. Basically, my day-to-day tasks are related to food contact materials, or in abbreviation FCMs, all sort of different FCMs, mostly low plastic and paper and board, but also glass, ceramics, silicones, etc. I do testing planning for clients, give some compliance assessment, things like that, basically all sort of different tasks that help them to prove that their materials are safe and comply with the local and also American and other regulations that are applicable for them. My background is in food science, but they needed somebody who is an FCM expert at Measure Labs, so that's what I intended to become for the last 3.5 years. In case you are not familiar with Measure Labs, we are I'm not sure if it's a growth company or a startup company, but it doesn't really matter. We are located in Vaalila, Helsinki, and we provide all sort of different testing services and also let's say consultative services as well. In terms of food contact materials, we help our clients to design the testing, conduct the testing, and also help them on the way with different type of issues. So, but we also are not limited to provide only the, let's say, microration testing. For packaging materials, we are also able to provide barrier testing, biodegradability, bio-based content, all sort of different things applicable to packaging materials. But that's about the advertisement part. So about the agenda of today. So quickly start with a short introduction. What are bisphenols and what are they used for? What is the, let's say, historic regulatory landscape in terms of bisphenols, and then kind of the whole beef of the discussion, how to test compliance according to these new regulations, and what type of limit would you need to apply in different cases. And there would be also a case example at the end to kind of give more practical approach on the whole matter being discussed. And I try my best to reserve as much time as possible for Q&A, because I mentioned that there are a lot of people who have questions on their minds. So, but let's just get to it then. Before heading further into the webinar, here are a few abbreviations you will see throughout the presentation. So just wanted to open them up here first, so whenever you see them, you know what's being discussed. So very surface level chemistry lesson. So bisphenols are a class of substances that share the same chemical backbone as seen here. For example, in BPA, the X is substituted with a dimethyl substitution. In case of BPS, it's a sulfone group, but the kind of similarity between those substances, that the backbone there is the same, but only the substitution in the middle of the chemical is different. And when we talk about derivative structures, then there can be also different type of substitutions throughout the molecular structure as well. This particular webinar will be mostly focused on BPA, BPS, and bisphenol A diglycidyl ether, because those are the substances that have been authorized for food contact at the EU level until today. So that is the kind of most relevant chemicals from the big scope of different bisphenols. So just a quick kind of review what they have been used for. I think the only kind of lesson here is that maybe not this particular audience, but let's say the wider public, there's an idea that bisphenol A is used as a plasticizer, which is not. I think it's because it's considered an endocrine disruption molecule, and people associate those with plasticizer. But in any case, bisphenol A has been used in manufacturing of the so-called polycarbonate plastics, but also filtration membranes, and it was previously also used to color developer thermal paper. BPA is used in manufacturing of so-called epoxy monomers, which are then used in epoxy coatings and epoxy-based adhesives. I cannot remember the exact year, but for some time now, BPS has been used to substitute BPA in thermal paper and receipt paper. But something like bisphenol B has not been authorized in the EU, but for example, in the FDA has been authorized to be used as a monomer in epoxy coatings. I kind of already mentioned this, but the whole fuss about at the moment is that bisphenol A in particular, but also some other bisphenols and bisphenol derivatives have been shown in studies that they are so-called endocrine disruptors. Basically, the structure is somewhat close to the structure of estrogen, so it activates the receptor partially, which has all sort of different negative health effects, especially in children who are still developing, where hormonal systems and homeostasis are very important for healthy development. And once they just study it more, they see that, okay, there is no really safe level for these type of substances, though. So the only kind of option seen plausible was to ban the use them, in particular in food contact materials, because food are such an important exposure route for these substances. I realized that maybe there's a bit too many slides, so I don't want to steal too much time away from the Q&A, so I will go through these slides quite quickly. But just to give you an idea about how these situations has developed over time. So let's say we started with a specific migration limit for BPA with 3 milligrams per kilogram, so not that low, but not that very high either. But as time went on, it was realized that it has these endocrine disrupting properties. So it was first banned in infant feeding bottles. And then in 2015, the temporary TDI was defined as 4 micrograms per kilogram. And subsequently, the specific migration limit in plastics was reduced from 0.6 to 0.05. And then this regulation was also extended to coatings and varnishes because the plastic regulation didn't, these type of materials weren't within that scope, so it required its own regulation for that. But in 2023, after the re-evaluation, the TDI was reduced by 20,000-fold to 0.2 nanograms per kilogram per, sorry, 0.2 nanograms kilogram body weight per day. And that value was then used as a basis for formulating the new regulations, mostly being discussed today. A bit more about the recent regulation considering ban of using hazardous bisphenols in certain food contact materials, or more specifically, it specifies only a few exemptions where you are allowed to still continue using. Otherwise, the use is not allowed anymore. Not all FCM are part of these regulations. The matrices are mentioned here, so it's not only plastics, but it's not every FCM out there. For example, paper and board are out of the scope of the final regulation. They were discussed in the draft, but any discussion related to paper and board were left out in the final official regulation. Here are listed the exemptions where the continuing use of bisphenol A, at least for the time being, is still allowed. So one example is use as a coating or varnish in very large tanks to transfer food, because the surface to volume ratio there is so low that the risk of exposure to BPA from such uses is low. But then again, also the manufacturers or user of such tanks still have to prove that there is no detectable migration. And the second use that is still allowed is use as a monomer in so-called polysulfone filtration membranes. And to my understanding, the reason is that there was no alternative to substitute it as a monomer there without compromising food safety. So that's the reason why it's still allowed to be used until any comparable substitute is available. Further discussion about the new regulation. So, of course, since this PP and BPS was, or BPS in all uses were banned, BPA was left to be used only in few situations. It was therefore deleted from the Annex 1 to show the positive list of the plastic regulation. The compliance limit enforced in the new regulation is basically that there's no detectable migration, and it was set as 1 microgram per kilogram. And I think this is only as a limit that is as low as possible, but still within the reason to be reached within the current technologies. But my understanding is that once the technologies develop further and there will be more sensitive methods available, basically the detection limit for those methods would be then applied. But for the time being, it's considered this. And this at the moment is being applied for the specific migration and also the content based on extractions. And if you want to show that the material does not contain any bisphenols, you have to use an extraction method. About the test methods that you use, to our best understanding, there is no official method, let's say, from European Union reference laboratory yet. But once those are available and recommended, laboratories are bound, or the manufacturers are bound to use those test methods in improving the compliance. So that's about the newest regulation. So a bit also what's happening on a national, in a member state level. I think the most famous one being the French national ban of bisphenol A that was extended to all FCM in 2015. Back then it was in conflict with the EU in the harmonized regulation, but they were still allowed to keep it without much sanctions, to my understanding. The scope of this is all FCMs, but it doesn't include every type of different articles, so it's limited to packaging, containers, and utensils. And similarly to the new regulation, it's mainly to avoid intentional use of BPA, so it doesn't really consider unintentional use. But since there hasn't been any harmonized way of testing this regulation has served, let's say, like a de facto regulatory reference whenever BPA content has been tested since 2015. Also in Germany, by the BFR authority, they have this long list of different recommendations for different type of materials. In their recommendation number 36, in the annex regarding specific restrictions on recycled fibers, they have defined a migration limit for BPA and BPS at 0.05 milligrams per kilogram of food. And also earlier, certain member states have set their own regulations banning use of BPA in FCMs intended for young children, but most of those regulations would become obsolete after the new regulations in force. So that's about the regulatory, let's say, a short history and the recent update on that on also national level. So I imagine a lot of people here are wondering at the moment, does this apply in my case? Do I need to test? And basically, how do I test? And I do my best to answer those questions today. But the first and foremost, I would like to still highlight that the number one solution is to do supply chain review and maintain a proper GMP. And so basically you can then confirm that BPA is not intentionally used in any of the materials throughout the supply chain, not by you and not by your suppliers. So then it mitigates the risk in a way that you can define that, okay, I'm not within the scope of this new regulation, right? So the risk of BPA presence there would be very low. However, there are certain situations where testing would be still a good idea or even required. If you use recycled materials, because recycled materials can contain some residual amount of BPA that is not fully in control of the supplier. And in case they haven't tested it themselves, it might become your responsibility to test it. Or if you modify the product somehow and you have to do some complementary testing in addition to what the supplier has already done. Also, if you cannot exclude the use of BPA in the manufacturing chain or the supply chain, you might do it to mitigate the risk there. And I think the most common, at least, or one of the equally common factors, is that you have a client that says that we have to have a test report that shows this, even if you are able to prove through supply chain review that it's not intentionally used, it's still required. But that is something that is not related to the regulation itself. It's just a special requirement from a third party in that context. So, okay, let's assume that you have to do the testing. So then next, what you think is like, how do I actually test it? And there are essentially three different routes. So you can do specific migration testing into food or food simulant. You can measure the content of bisphenol A or bisphenols from the material, or you can do a specific migration test based on extraction. And essentially also the second one in the middle you can also use to measure specific migration by calculation, but I will explain that a bit later. I think this is the most familiar one and the most self-explanatory and evident, is that you just put the article or the film or whatever pellets in contact with the food simulant, and then you keep it there for a certain time at certain temperature, after which the sample is treated if necessary and then analyzed for the content of the specific analyte. So from the testing point of view, it's relatively straightforward, but there are some factors that you still have to consider when proceeding with the testing. And I think the largest headache is like what would be the appropriate migration conditions, what should be the simulants, what test temperature should I use, what migration method should I use, things like that. And unless you're familiar, the Joint Research Center has a very good so-called kitchenware guidelines. I cannot remember by heart the full name, but it essentially describes guidance temperature, so the guidance conditions for a specific migration according to the type of material and the intended use. So let's say if it's utensils or a plate or something like that, it says that, okay, the specific migration should be done according to these conditions. And in the most recent update, they also included tool tables for paper and board as well. So for those type of manufacturers or working in that field, it's very, very useful. So yeah, so those kind of things have to be considered. And if this feels like an overwhelming task, we are happy to help with this work as well. And the second part, then I think where there's the most amount of deviation between laboratories, how they approach this, is then to analyze the content based on exhaustive extraction, which means that the aim is to extract 100% of the analyte from the material to show the absolute content there. And then you have to, in migration, it's pretty well defined in the standards how you conduct the testing. But here, then you have to think about what is the matrix, what is the analyte that you want to analyze, and how you perform the extraction to make sure it's reproducible and effective. So you have to think about, okay, how should I pre-treat the samples? If it's a film or paper, you cut it in small pieces, no issues there. But if it's a solid article, the solvent might not be able to penetrate the material very deeply. So then you would need to do cryo grinding or other, or apply other method that basically disintegrates the sample to enhance the extraction. And then there's options for different extraction solvents. But to kind of cut the long story short, I think the most important factors are there that regardless what is the method, that the laboratory method has data or optimally would have data about the recovery for that analyte from that specific matrix, unless there is a standardized or validated method for the specific case. For example, testing of PP and BBS from thermal paper has been validated in literature where the extraction was done with water under sonication. But yeah, those kind of things need to be considered. So making sure that obviously if it's an accredited method, that is also a good proof of quality as well. And in some cases, you might have a limit based on the regulation or from the customer that you have to comply with certain level for content and certain level for migration. And in case the detection limit is low enough, and the amount of the residual amount is low enough for the content, you can essentially do migration modeling where you assume 100% of the analyte migrates. And if that is still within the specific migration limit, you don't have to do a specific testing because there's no scenario where it could be exceeded. And so this is a kind of like a simple method. There is a more sophisticated way as well of doing it, where you also apply the diffusion coefficients for, let's say, BPA in polyethylene terephthalate, but then you would need to have those numbers for the diffusion coefficients. So that's not then like a full migration, but it kind of estimates how it would actually behave in a real migration scenario. And the third option then would be estimating specific migration from extraction. And this would be applied in cases where the true migration method is not possible, like let's say non-coated paper where the simulant just penetrates into the material. It's not technically possible to do it. So in essence, you have to do extraction and then recalculate that into migration. The results from, let's say, exhaustive extraction can be used there, but that then would really overestimate the true migration in most scenarios. So here is something kind of in between, that you have an extraction that would exceed the migration but not be exhaustive. And for paper and board, there are 3 different standards with either water or solvent, simulants, or extraction solvents to do these extractions in a standardized way. Typically, water extraction is used if the content is intended for water-based foods or if the analyte is water-soluble. Vice versa, the solvent extraction would be done as a worst case for lipophilic substances or in case where the contact is limited to fatty foods. However, when there was these statements given to European Commission for the new BPA regulation, the SEPI actually had proposed there that if paper and board would become part of the scope of that regulation, that the reference method for doing the extraction would be the cold water extract, and this wouldn't be like an exhaustive extraction, so this would be a proper way to simulate the migration in the worst case scenario, and that would be then calculated as a migration. And the reason is that they have specified in various different documents that the fibers in the paper can swell in contact with ethanol. So that's why they propose the use of cold water extract in this scenario. However, this is only proposal from industry partners, so this is not like an official guideline in any case. So interesting to see in the future if there will be like an official way on how you would define this in paper and board as well. Here it's just like an FYI about the standardized and methods for analyzing BPA in different contexts. But you can see it's mostly about analyzing the extract, analyzing the simulant, etc. So what is kind of lacking, in my opinion, is some kind of harmonized ways of doing the actual extraction of BPA from different materials. The French law has this standard way of extracting, but that doesn't really take into account how well it behaves with different type of FCMs, because it's the same method for essentially all. And it doesn't even discuss anything about pretreatments or things like that. But I guess the point is there is not to fully extract any BPA, just to show that there is no intentional use of it. So I guess that's kind of why it's not even aiming to be a perfect method. But that needs to be kept in mind, that when this method is applied, that it's not intended to be like a fully effective extraction, even though it's very commonly used for that purpose. So the last but not least would be discussion, and I think this would be the most relevant case for most people. If the bisphenols are either expected or unexpected NIAS in the material, how you should evaluate that result. In general, if the BPA is not used there, it's unlikely to be there. But some materials, in particular recycled materials, have a higher risk of BPA or BPS presence. So basically, even though these hazardous bisphenols are banned used, but the regulation is specific that it's only for regarding intentional use. It essentially means that unintentional presence, it's not forbidden per se, because even in plastic regulation it says that unauthorized substances are quote unquote allowed to be there, but whatever is there and whatever migrates into food is then subject to risk assessment. And so then the next question is, okay, then I test and I presume that it's there as a NIAS, and I have detected some BPA. How then I should evaluate this result? And at the moment, before heading to this discussion further, there will be hopefully soon more let's say Q&A guidelines from the Commission's direction that would give a more definitive answer to the topics I'm discussing here. So let's say that this is the evaluation of the field as it is at the moment, but hopefully more concrete guidelines will be available soon. But regardless, I will start with, I have divided these different topics depending on paper and if it's a paper or plastic material. And at the moment, the applicable limit, let's say the gold standard in a way, would be the annex from BFR 36, which would be the 0.05 milligrams per kilogram of food. And it's based on the previous EFSA evaluation from 10 to 15 about what would be the tolerable daily intake. And just one side note is that BFR has published opinion in 2023, where they state that they don't agree with the very low limit from EFSA. And they have proposed a lower TDI than previously, but still 1,000-fold higher than EFSA did. And as just an academic exercise, if those limits would be used to calculate the specific migration limits as has been done before, just based on TDI, it would be 12 micrograms per kilogram of food. And if 20% allocation factor is used, it would be 2.4 micrograms per kilogram of food. And you can see the formula at the end of the table. And the allocation factor here means that previously in 2015, when the new TDI was converted into specific migration limit, they just didn't use the 100% of the TDI, but they give FCM 20% allocation because there are other possible exposure routes for bisphenols apart from FCM. And if such approach would be used, or the calculation would be done similarly today based on the BFR opinion, then the migration limit would be this, but the future will show how they will implement their own opinion in the future into BFR 36. Then about plastic, so I kind of already discussed this, that in 2015 there was a new risk assessment made, and due to which in the plastic regulation the specific migration limit was reduced to 0.05. And then it went down drastically. And based on those calculations, the migration limits would be ridiculously low. So I imagine that the new limit is more or less a technical compromise, because based on toxicological numbers, it should be even much lower than the current one in the regulation. But yeah, I will come back to this, like what would be the applicable limit in this table then. But before that, a small case example in the at the end of the presentation. So let's imagine that we have a client that manufactures paper bag with recycled fibers in them that is intended to transport mostly packaged good, but there might be some incidental contact with food. So direct contact. So as a conservative approach, because no migration test can be done for this particular bag, cold water extraction is done from the paper, and it's analyzed with liquid chromatographic tandem mass spectrometry, which is a standard method for analyzing PPA. Yeah, forgot to mention that. And based on that study, we get a residual level that is detectable, but the limit is migration. So how do we calculate that? So then we need the grammage of the paper bag. We need to consider what's the surface to volume ratio. In this case, it's not specifically defined because you don't have a particular shape and size and the amount of food that goes into it. So you use the conventional one. And putting those numbers together, we get a calculated migration of about 0.02 milligrams per kilogram of food. And then we assess that in the specific use, with specific BPA, this would be compliant with BFR 36. Yeah, so kind of going back to where I listed the three different options for measuring the migration. So if the material is if it's plastic or coated in a way that it can withstand the actual migration test, then that obviously it's a preferred way of measuring the migration. But if not, then or you can alternatively use the data from the exhaustive extraction, assuming 100% migration or doing migration modeling. Or if it's uncoated paper, you're pretty much out of luck. That you have to really do it based on extraction. And obviously, if you want to measure content, you have to have a method that is effective enough in extracting the material, so it would be exhaustive extraction in all cases. But I guess the most controversial slide in a way from this presentation. So a bit more explanation here before heading to the Q&A. So if the bisphenols are present as NIAS, what limit would I apply, or should I think would be possibly appropriate to apply in each case? And the explanation here for the plastic 0.05, it's because the new regulation 1, it doesn't control intentional presence. And the second, it has a transition period until next year's July that states that materials that don't comply with this regulation but comply with the previous version of, well, let's say the previous limit, are okay to remain in market, or sorry, so are okay to enter the market at the moment. And since we know that, especially if it's recycled material, there's no way to comply with the very low limits very often. So then it's more reasonable at the moment, at least, to consider this as an ad hoc limit for let's say, plastic with recycled content. With paper, it's a more clear cut because you have a specific limit defined in BFR 36 in that context. But this only considers really migration. And about content, in my opinion, there is no really like defined limit what you need to comply in terms of NIAS. But if you anticipate or know that there might be these bisphenols as NIAS present, doing monitoring of that as part of your quality systems would be important. And also it needs to be noted that in the new regulation 2025/351, if you are an intermediate player in the manufacturing chain and you detect levels of bisphenols, any of them, in a way that might become a problem for compliance assessment in the next guy in the line, you would have to be open about reporting or like informing this further down in the chain. Yeah, so ending a bit also with some advertisement here. So as I mentioned, all these services or tests discussed within this webinar are available for us. We are a laboratory service provider, so there's a catch, as it tends to be. But if you're interested, please just send an email to me or Fanny. Before, was there any questions sent to the chat yet, Fanny?
Not yet, so I think we can take the pre-submitted selected questions that we had, and if you have some questions that pop into your mind, please send them in the chat and we will answer them as well.
Yeah. So there were a few questions that were sent before. And while I go these through, if you have anything on your mind, just write in the chat or raise your hand and open the microphone. Whatever suits you best. Okay. Let's just hide the notifications. So the first is, are non-food contact uses of PP also restricted? Does this regulation affect the use of post-consumer plastic in packaging with bisphenols besides BPA are affected? At the moment, the regulation is very specific. It's only about food contact materials, so it doesn't consider anything about other products. Those are controlled by their own specific regulations, such as REACH. And if there are some specific limitations in that specific product field, those obviously apply. But this specific ban that was published. It's only for FCM. And about using post-consumer plastic in packaging, it really depends if it's intended for food packaging or not. So if it's intended as food packaging, you have to comply with the plastic recycling regulation 2022/1616, and that essentially means that the input that you put in the recycling system has to be also in compliance with the plastic regulation and with the new BPA ban. So basically, in that way, it applies if it's food packaging material. So you cannot use post-consumer waste to produce recycled plastics where you cannot, if you don't know if it's food contact grade or not. But if it's not a food packaging, then this ban is not applicable and it doesn't meet the use. Sorry, the last question about which bisphenols are affected was not answered here, but it's answered later on the question, so that will be covered. I think I somewhat answer this. So if the supplier says that they don't intentionally use it, in my opinion, it's not required, but it depends. So well, you can kind of go back into the slides also to see in which cases we would recommend it. So on having recycled content and without having idea what are the levels of BPA there, or you cannot guarantee from the supply chain review that BPA has not been intentionally used in any of the point. But if you have all these parts there, I don't really see why you would need to do testing, because there is a million chemicals out there. It's not possible that you test all of them. About the legislation applicable to metal packaging in general, if you think that the legislation in the future will be applicable to all cans or only food contact cans. And this kind of goes back what was discussed earlier. The new regulation is only applicable to food contact materials. So if it's a can material for any other use, I don't see a reason why, let's say, epoxy coatings wouldn't be allowed to be used still. And when we talk about metallic food contact materials, and if it's intended for contact with food, if it has an organic coating and varnish, that cannot then contain any hazardous bisphenols anymore. So it cannot be, to my understanding, it cannot be this. There's a bit of an ambiguity, but my best understanding is that these epoxy coatings are no longer allowed, but take that with a grain of salt. But in any case, in the big picture, that coating would be within the scope of the new regulation. But if it's a non-coated metal, I don't really see why you would have BPA there, because it's an inorganic material. And if it's only steel, why you would have BPA, why you would use BPA. So in that context, I don't see this regulation at all relevant in that case. How to assess all bisphenols and bisphenol derivatives, and I think this is kind of headache that people maybe get some flashbacks with PFAS testing, because there are 4,000 or 10,000, I don't remember how many potential chemicals, and there's no way to test all of them. Fortunately, there's not that many bisphenols, and also in this case, the regulation specific that it's within its scope, there are bisphenols that are considered, and so the definition for being hazardous is that it's listed in the CLP regulation as category 1, 2, or 2B mutagenic, carcinogenic, toxic to reproduction, or category 1 endocrine disrupting. We actually went through this CLP regulation recently, and at least based on the gas number search, I was only able to find BPA or BPS there. And also because these substances were previously used as allowed substances, food contact material, these are the most common and relevant contaminants. So I think these should be the main focus. The other substances are very possibly unlikely to be there, apart from special cases, because they haven't been allowed to be used in food contact materials, let's say BPF or BPP or any other BP variants. So in my opinion, you don't really need to stress too much about if you need to test all of the sort of different bisphenols out there. But however, there are options available to do these called screening packages, where all sort of different bisphenols and bisphenol derivatives are screened, and those are focused on a risk assessment basis to cover the most relevant ones. But can they essentially cover 100% every possible bisphenol derivative that could be harmful? I obviously guess not. But then risk of having those present in the material are also quite low to begin with. Yeah.
Now we do have some questions in the chat, so I think we can maybe continue on those, starting from Marty Kubovic's question that goes into the analysis methods a little bit more. He asks, have you tried to use GCMS for BPA measurement using derivatization agent? Do you have any insights on that?
I have no personal experience. I know that this is possible, but let's say on an anecdotal experience and seeing the literature around the topic, let's say 99% of the cases it's done with LC-MS, and the methods are most typically validated with that. But obviously, from technical point of view, I don't see any reason why it couldn't be done with GC-MS also. But it just seems to be that it's most commonly done with LC-MS.
Yes. And then we have Anselma asking about, are there specific migration modeling methods you would recommend for BPA?
There are good literature about this, especially modeling BPA migration from recycled PET or for PET. And to be honest, I don't understand the philosophy on the migration modeling side, where you apply the diffusion coefficients and things like that 100% perfectly. So personally, I have mostly used where you just assume the 100% migration, and that's pretty easy to, let's say, relatively easy to do in an Excel. And there are several different ways you can either measure like a test piece, its dimensions, and knowing its thickness and its mass, you can calculate how much material you have. Oh, sorry. Well, you don't have to know the mass even. You just need to know the surface area and the mass. And then based on the residual content, you can calculate the migration there. Or you can use if you know the thickness of the material and you know the density and you know the residual content, just using those three values, I believe you can do these simple calculations.
Yes. And as a quick reply also about the question on PFAS testing, yes, we also offer PFAS testing for FCMs. I sent a link to the chat with a page where you can read some more, and then if you want an offer for your own purpose and to discuss it with experts, feel free to reach out to us. Then we have a question from HC. What is the extraction conditions used for BPA testing on polymers?
There are basically several options. What I have seen are used, typical solvents used are acetonitrile, methanol, and dichloromethane. And I think regardless of what solvent is used, from technical point of view, the most relevant information is the recovery effective in that particular extraction method as well, because you can enhance the extraction by grinding the sample, you can enhance it by doing SOx-led extraction, you can enhance it by doing ultrasonication of the material, you can also do all of different tactics to enhance the extractions. So there are several different options, but I don't have in mind what would be the kind of gold standard there. But well, one example could be like a long, let's say, hours of extraction with methanol under SOx-led. That's just an example.
Yes. We have a a quite related question from Antti, so let's take Marco's question afterwards. But Antti asked related about if we have some experience on how effective the EN645 water extraction is compared to the acetonitrile extraction in case of uncoated paperboard.
It really depends what is your aim. In my opinion, if you want to, basically in the slides where I mentioned about using this cold water extract, and it was recommended by Seppi, that Seppi's idea wasn't to use it as an exhaustive extraction method. It was used to simulate migration, actually, because in their based on their technical data, using actually the solvent extraction would be more effective. I'm not sure if acetonitrile specifically has this swelling effect similarly to ethanol, but typically acetonitrile tends to be very, very effective in these extractions. And I cannot remember by heart exactly the name of the guideline, but as a, let's say, standard way of doing extraction-based analysis of NIAS, performing acetonitrile extraction for 24 hours at room temperature is recommended, and that's the same method used in the French regulation. But there is one study that was done in thermal paper in Poland a few years ago, where they did this very effective method or extraction method validation, where they didn't use acetonitrile, but they used water and methanol with different levels of concentration and different extraction times and different sonication times. And in that study, they found that with thermal paper, at least the most, let's say, optimal extraction was with water for roughly half an hour under sonication. And in that case, it was discussed that under sonication, the water is more effective in disintegrating the structure of the paper than methanol is. So, but I haven't seen like this like direct comparison next to each other in a way. But in any case, whatever, like I mentioned, whatever the extraction method is chosen, it's important to know that the recovery in that specific matrix is high enough. And for example, in that specific paper, something like for uncoated paper, this type of approach would work quite well with BPA and BPS doing this water extraction under sonication. But if it has lamination, then I don't know, the situation might change quite a bit.
Yes. We have a quite long question from Marco. It was mentioned that there is no official method in force by the EU yet. However, BPA shall not be detected using a method with a LOD of at least 1 microgram per kilogram. How is one supposed to validate this method? Is there a method to reference to? Is there an official way to obtain samples with a defined content of BPA to use for validation work, especially when measuring the BPA content in plastic material?
Yeah, to my understanding, there are these reference materials available to do the method validation. Just one thing I want to clarify, that if we talk about the analytical part where you have to reach this very low detection limit, there are already certain reference methods available that have been, let's say, internationally recognized. Let's say analysis of BPA from food simulants or analysis of BPA from extracts of paper and board. So there are ways of increasing the LOD by concentrating the sample in a manner that you don't lose the analyte. That's one option. And just it's, you know, it follows the principles of any type of method validation or development in the laboratory field. So basically, you just you have to do the quantification range, or in this case, you have to have the limit of detection in that area, and it has to be basically, the detection limit has to be in the original extract, but if you are able to concentrate it in a way at the instrument side, you might see a much more concentrated sample. But once you calculate it back, then the detection limit in the original sample would be that. But in my understanding, the most effective way would be to concentrate the sample in certain way that there would be no limitations at the instrument's end to reach this level of detection.
Thank you. Then we have from Marta a question. As a supplier of basic polymer pellets, we are frequently asked about the presence of bisphenols and bisphenol derivatives. However, having no process source of BPs and based on our suppliers' declarations, there are no intentionally added bisphenols. In my opinion, we can really test at least the content of main bisphenols. Is there any other recommendation towards testing for producers of polymer pellets not using bisphenols?
That's a quick thought. I think in those situations, having a method that is sensitive is very sensitive to show that this, and based on effective extraction, to show that the content of different bisphenols are not detected. At the moment, with BPA, it's possible to reach the regulatory limit, but it's not very widely available, at least, or I haven't seen a method where you could cover all sort of different bisphenols according to the 1 parts per billion limit. You can reach something like 2 that I have seen. I don't see in this case it would deviate in the examples discussed here, because I would see that the method still to perform the actual analysis of content would be the same. I think it's really part of your own quality management. If you see that you want to do this testing to reassure your clients or to kind of extend your due diligence, basically, if you have this documentation that the bisphenols have not been used, I don't see why there would be a legal mandate to do this testing in any shape or form. But just talking about the technical way of doing the analysis itself, I don't see it would differ from the other examples.
Yes, I think we can take one last question before wrapping things up. Marco is asking about our PETs. They have a certain amount of impurities that use BPA as a starting substance, for example, epoxy and polycarbonate. How can we differentiate between chemically bound BPAs, as in PC and free BPA?
Yeah, that's a very good question. I don't have an immediate answer there, because I haven't not seen data if these extraction methods that I described, let's say there's a nitrile extraction or Soxhlet extraction with methanol, if those are like so harsh that they would depolymerize these type of polymer, sorry, the PC there into free BPA. Yeah, I have to take a look at that and get back to that later.
Let's do so. Then I think we can start to wrap things up. Can you, Nico, take it to the last slide that has the QR code for the,
of course,
the feedback form? So you can, we would really appreciate to get feedback on this, both what you liked and if there is something that you wish we would do differently on future webinars. And you can also in the form leave suggestions on topics that you wish we would cover. We are planning to do a couple sessions like this during the autumn and are happy to take into account suggestions from you guys. I will also send the link to the feedback form with email after the webinar. So if you don't have time to answer it now, you can do it also a little bit later. And I will also be sending the recording and the webinar slides to you, so you can get back to it if you want to. But otherwise, we thank you very much for attending and for all the really good questions. We were happy to see that you are very invested in the topic and can ask good questions. Do you, Nico, have any closing words or other things that you want to mention?
Well, yeah, I really appreciate that so many people took time of their day to be here today, and I guess we are all looking forward to for the further guidelines from the Commission level, so we can have some clarities here on the topics that were discussed.
Yes, good. Thank you, and I wish you all a nice continued afternoon for today.
Have a nice rest of the day.
Bye.
Bye-bye.